cannot wait to learn about what we're going to learn about circles today, right? Is Miss Greta here today? I can't tell. I saw Greta got a new kitten. Okay, here we go. So if you remember, just a quick review. No, up here. Okay. So if you have a central angle, so kind of warming back up here, right? And 10.2, if we have a central angle is an angle that's inside a circle, right? And for example, if a central angle actually meets at the vertex at the center of the circle, okay? So you'll see here, this is a circle. It has a central angle of ACB, which is 50 degrees, right? And so then if I want to measure the arc of my circle, the arc of AB, that's also 50 degrees. So central angles are kind of the easiest angles to measure, right? Because it's just basically the same as the angle measurement on the inside equals the angle measurement on the outside. We like these, right? Super easy. Then we get a little bit more complicated, but not too bad when we get down here to 10.4, which is what we did on Monday. And this is the measure of an inscribed angle. And there's a theorem that goes along with that. So an inscribed angle, you can see right here, an angle whose vertex is on the circle and whose side contain chords in the circle. So it's basically when you draw an angle that meets at the edge of a circle instead of the center of a circle. Okay, and so this is a little bit different. If we have this angle ADB, then the arc is going to be double the size of the angle. So if ADB was 50 degrees, then the measure of arc AB would be 100 degrees. Or if the measure of arc AB is 100 degrees, then the measure of ADB is 50 degrees. So a little bit more complicated, right? They're not exactly equal to each other, but they have this relationship. So now we're going to switch gears to 10.5. And the reason that I wanted to show you that is because we kind of have a similar theorem to go along with this. So let's open this in a new page. Make sure you get your theorem sheets out, right? Okay, so now we're going to talk about angles that are tangent to a point on the circle and the arc that is formed by them. Okay, so we were talking about those two that I just showed you were inside the circle, right? One was a central angle, so it met at the center. One was inscribed, so it's inside the circle. Now we're going to talk about a tangent and a chord, and when they intersect, then the measure of the angle formed has a relationship to the arc. So that was a bunch of words, but if you look at this picture here, it will kind of become clear. Okay, so do you remember what a tangent is the first thing? Anyone remember what a tangent is? So a tangent is a line that intersects the circle at exactly one point. Okay, so this line here, no, I don't think it has a name. This line here, if you would zoom way into your circle, there's only one little point where it intersects the circle, right here at A. Okay, and then we have a chord. Remember, a chord is a line segment whose endpoints are in the circle. So you have chord AB that's just inside the circle. All right, so when those two meet, there's two angles that are formed. We have angle 1 right here, right? And we have angle 2 right here, red and green. If you look at angle 1 and angle 2, does anybody know what those add up to? Anybody? Angle 1 and angle 2 should add up to 180 degrees, right? Because they're on a line, so they should add up to 180 degrees. Okay, just a quick review of that. All right, so if I look at the measure of angle 1 here, okay, this red measurement here, that is equal to 1/2 the measure of arc AB. One half the measure of, if I can write, the measure of, I'm just going to write it this way, measure of angle A, or arc AB. Oh, that's horrible. Hold on. Go back, go back. There we go. Measure of arc AB. So again, we have this relationship where we have an angle, but this angle isn't inscribed in the circle. This angle is formed by a chord and a tangent. And that measure of that angle is equal to 1/2 the measurement of the arc. Okay. What about angle 2? So angle 2 is in green. The measure of angle 2 is equal to 1/2 the measure of arc BCA. BCA. So it's this whole big arc here that goes all the way around. If you take half of that, that's going to give you the measure of angle 2. So if a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. Okay, so make sure you write that down because this one I think is not quite as intuitive. Make sure you get that on your theorem sheet. Okay, and then let's try a couple examples with this. So number 1, right, says line M is tangent to the circle. Find the indicated measurement. So they show you that arc AB is 132 degrees. Can anybody tell me what the measure of angle 1 is? Is it 132 degrees times 2, or is it a half of 132 degrees? You can put it in the chat if you want. All right, I'm assuming you guys are all chatting. You're just half. There you go, Sophia. Thank you. So it's half of that, right? So the measure of angle 1 is half of 132 degrees, which happens to be 66 degrees. It's hard to draw sixes on your computer. I'm having a hard time drawing today. 66 degrees. I'm going to go with my mouse. There we go. Okay. All right. What about B, the measure of arc EFD? EFD. And they tell us that the measure of angle, of that angle right there, is 110 degrees, right? So the measure of arc EFD is actually going to be double 110 degrees. So it's going to be 220 degrees. Pretty easy peasy, right? Okay, I have some more theorems for you. Yay, right? Okay, theorem 1012, angles inside the circle theorem. If two chords intersect inside a circle, so remember a chord is just a line that's somewhere in the circle, it does not go through the center. You'll notice neither of these are going through the center, right? If two chords intersect inside a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. Whoa, that's a whole lot of words, right? So let's kind of break this down in pictures. I think it's helpful to look at this, right? I might make this a little bigger. Whoa. Yeah, that's all right. We'll make it a little bigger here too. All right, so the measure of angle 1, you can see angle 1 is right here, right? The measure of angle 1 is equal to 1/2 times the measure of arc AB plus arc DC. Okay, another kind of weird little theorem that you definitely want to put on your sheet because it's not as intuitive, right? So if I want to find the measure of angle 1, I basically I'm going to take the average of arc AB and DC. So I'm going to add these two arcs together and I'm going to divide by 2. I'm going to multiply by 1/2. Okay? So that's going to give me the measure of angle 1. And guess what? This angle 1 over here should be congruent to this angle over here, right? Because they are, do you remember what those are called? Vertical angles, right? Those two, since they're two lines that intersect, those two are the same. Okay, so then if I go to angle 2 down here, right? Angle 2 is the one that's right here. It's a crazy looking angle. So angle 2 is right here in green. Okay, so the measure of angle 2 is equal to 1/2 the measure of arc BC plus the measure of arc AD. So again, it's like you're basically taking the average of the two arcs. You're adding them together and you'll figure out what the measure of 2 is, which is also the measure of the opposite angle. Okay, and there's more theorems. But wait, there's more. This theorem is actually written, let's see, I'm looking at your theorem sheet that I handed out to everybody. We have 10-2. Okay. So you might need a little bit extra room for 10-13 on your paper. And this is actually, I left it written out on your, keep scrolling, sorry. Left it written out here. So angles outside of the circle theorem. So let me explain what these mean here. There we go. That helps us out. Okay, so what I was trying to point out in the beginning is first we have the angles that are inside the circle, right? And then these two theorems that we just talked about talk about, well, this one talks about a chord and a tangent that form an angle and how that has a relationship to the arcs, right? And then theorem 10-12 talks about if you have two chords that intersect on the inside, what can we figure out what the angles are? And then 10-13 actually talks about what happens if our angles are outside of our circle. Does that have some relationship to the arc of our circle? And it does. So it says if a tangent and a secant, two tangents or two secants intersect outside the circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. Okay, so what does this mean? It's giving you 3 different scenarios, but the formula remains the same. So the first one is if a tangent and a secant. Okay, so this is an example of a tangent and a secant. Okay, or if you have two tangents, this is an example of a circle that is intersecting outside with two tangents. See, the tangent just hits the circle at one spot. Or two secants. Okay, so this is the example of two secants. So they're saying this theorem is true whether or not your lines are tangents or secants. This theorem works if they're intersecting outside the circle. Okay. And so this is how this theorem works. I'm going to start with the tangent one because I think it looks the most clean. Okay. So if you want to find the measure of angle 2, okay, it's equal to 1/2 the measure of arc PQR, so this is PQR, minus PR. So basically the big arc on the outside minus the arc on the inside, divide that by half and you will get the measure of angle 2. Okay, so let me color code this a little bit better for this next one. So same thing, what if I have 2 secants down here? Okay, so the measure of angle 3 is equal to 1/2 times the measure of arc XY minus, and here's XY is this one, right? XY minus WZ, which is in here. Okay, so you're taking basically the bigger arc that's formed by the angle, subtracting the smaller arc and dividing by 2, and then you'll figure out what your angle is. And then same thing here. The measure of angle 1, right, is equal to 1/2 times the measure of the bigger arc, which is BC, minus AC, which is this arc formed right here. So the formula is the same for all of those. It works for secants, 2 secants, 2 tangents, or a tangent and a secant. Okay, that's a lot of theorems. Now let's actually do some problems that have to do with this, with our theorems. So hopefully everybody got a chance to start writing those on your paper. Okay, so let me pull up some of these problems here. Okay, so the first one, example 2, find the value of x. So the chords FH and GJ intersect inside a circle, all right? And we want to find the measure of x, so I need to look at my theorems and say, all right, what theorem does this look like? And this is definitely 1012, right? Angles inside the circle theorem. So this theorem says that if I have an angle that's made by 2 chords, then I can basically take the 2 arcs. I need a different color. I can take arc FJ and arc GH, right? Add them together and divide by 2, and then I'll find the measure of angle X. So if I write this out, the measure of angle X equals 1/2 the measure of arc FJ plus the measure of arc GH. Okay, so 1/2, the measure of FJ is 112 degrees, plus the measure of GH, which is 140 degrees. And if I do that math, I end up with, math magic, 126 degrees. So the measure of angle X is 126 degrees, and this is thanks to theorem 1012. Okay. All right, example number 3. Find the value of x. So now we actually have an angle that's outside the outside the circle, right? X is outside the circle. We have a tangent GF and we have a secant GJ that form this angle. So now we definitely want to switch gears and we want to use theorem 1013, right? So theorem 1013 says that the measure of angle X is equal to 1/2. All right, the measure of which arc? My bigger arc, right? Of measure of arc JF minus the measure of arc HF. Okay, so we're going to have 1/2 times 170 minus 72, which is 1/2 of 98, which is equal to 49 degrees. So X should be 49 degrees. Okay. Example 4, we don't have any homework problems with that. So we're going to skip over number 4 and actually number 4 on your paper. But there's 3 more examples that I want to make sure we do. And then that's actually it for this section. So we're not actually doing 4. So I'm going to give you guys I'm going to give you 5 minutes. I want you to try 1, 2, and 3. Okay. Try them on your paper, see what you get, see if you get confused, figure out which theorem you want to use, and then we can, then I'll go through each of them. So go ahead and start on those. If you get done, you can tell me in the chat or you can send me a message and I will tell you if you got it. So go on 1, 2, and 3. Okay, I'm going to give you guys one more minute. Okay, so hopefully you guys got these all. I didn't see any messages in the chat, but hopefully you guys figured all these out. All right, number one, we want to find the measure of arc ACB. Okay, the measure of arc ACB. So first up, which theorem am I going to use to figure out the measure of arc ACB? I know you guys are all chatting, yelling at your computer screens that we're going to use theorem 1011. Right? This is theorem 1011. Because what this is we have a tangent and a chord that intersect, right? And they form an arc, or they form an angle that tells us what the measure of the arc is. So our angle is right here. It's 120 degrees, okay? And we know that the arc measurement, 1/2 of the arc measurement equals 120 degrees. So that means that the measure of arc ACB is 240 degrees. All right, so that one should be pretty good. Number two, which theorem is this going to be? Number 2 is theorem 1012, right? So kind of try to confuse you a little bit because this is angles inside the circle. So if two chords intersect inside a circle, then the measure of each angle is 1/2 the sum of their angles. If we kind of just look at our chords going from F to H and J to G, we can kind of see what that looks like. Now, the interesting thing here is we want to figure out, they didn't explicitly say, but we want to figure out what arc FJ is, right? We want to figure out what X is, which is arc FJ. Okay, we know what the opposite arc is. And if we look at theorem 10.12, we know that there's some relationship between the angles that are made on the inside and the outside angles, right? But 52 degrees actually helps us out with this arc length and this arc length. So how do we figure out what the measurement of this angle right here is? Well, I know that this 52 degrees plus my angle F toward the center to J, this angle here, plus 52 degrees adds up to what? 180, right? That adds up to 180. So I know that this angle here, it's hard to see, is equal to 128 degrees. Okay. So now that I figured out this is 128 degrees, and that's this angle in here. That's because 128 degrees plus 52 degrees equals the whole line 180 degrees. So now that I have that, I can use theorem 1012 to figure out what is arc X. All right. So 128 degrees, right? My angle that's formed is equal to 1/2 times the measure of arc FJ plus the measure of arc GH. Okay, so if I fill in the blanks, I have 128 degrees equals 1/2. What is the measure of FJ? That's X, right? And GH is 144 degrees. So who remembers their algebra skills? How are we going to solve this? Hopefully you all did, right? So first, let's actually multiply both sides by 2. So why did I do that? If I multiply both sides by 2, then I get rid of my 1/2 and I don't have to deal with my fraction. So 2 times 128 is 256 equals X plus 144. Okay, and then I subtract 144 from both sides. You can hear my mouse clicking away here, trying to write nicely here. And we figure out that X equals 112 degrees. So my arc up here, FJ, is 112 degrees. Okay, did everybody get that? You guys are all geniuses, get gold stars. Okay, my last problem here. I used theorem 1011, 1012, so I think I'm going to use 1013. No, I am going to use 1013, and that is because I have two secants that make an angle outside of my circle, right? So the formula for this is going to be the measure of angle G, right? The measure of angle G equals 1/2 times the measure of arc FK minus the measure of arc HJ. All right. So if I take FK, this arc, and subtract this arc and divide by 2, I get 26. I'm going to make my paper magically longer here. I'm going to switch to black so you can see a little better. Okay, so the measure of angle G is 26 degrees, right? That equals 1/2 the measure of FK, which is Y, minus 30. All right, so now I'm going to solve this. To make it easy on myself, the first thing I'm going to do is I'm going to multiply both sides by 2. Okay, that's because that gets rid of my 1/2. I don't have to deal with it. So 2 times 26 is 52 equals Y minus 30. I'm going to add 30 to both sides. And I find out that Y equals 82. You guys got all 3 of those right? Have you tried them?
Yeah.
Awesome. Everybody gets a gold star. All right, so this is 82 degrees over here. So the other thing you want to do is look, does that seem reasonable? Well, yeah, this is 30 degrees. This is 82 degrees. That seems about right, right? Seems good. Okay, so that is everything for 8.5. Again, if you didn't hear at the beginning of the call, on Monday, Mrs. Cooksey is going to be there. She's going to teach you 8.7. So it's kind of a standalone section about how to write and graph equations of circles. And then next Thursday online, I'm going to do 8.6, which is find segment lengths in circles. So I know you guys can't wait for that. So we'll basically be finished with chapter 10. Did I just say 8? She's going to do 10.7 and I'm going to do 10.6. And we'll be finished with chapter 10 at the end of next week. So, all right, that's all I have for you guys today, unless you have any questions. If not, I hope you have a good week. I'll miss seeing you guys on Monday, and you can email me if you have any questions. So, thanks for coming, guys.